George found a leaking pipe in a basement. Okay. His dad called the plumber, but the plumber can't fix it for 10 more days. Okay, since it's a slow, steady leak, George put a bucket under the pipe to catch the water. George needs to keep track of how fast the water is filling the bucket so that it doesn't overflow. Okay, so we'll fix it in 10 days. George measured the height of the water in the bucket after 1 day and after 3 days. So one day he found there's only basically 0.75 of an inch height of water in inches. So this is not even 1 inch yet in 1 day. So it's barely leaking. And this is 3 days, and it only will fill 2.3 inches in that bucket. Alright? How fast is the water filling the bucket? So what they're doing here is basically going, this is x1, y1, x2, y2 here. Little numbers, not a big one, then where it's not x times 2, it's little 2's. If you do that, you get, as you can see, 75, that minus that, these two, and then in the same order of 3 minus 1, get that. Because it says calculate how fast the water is filling the bucket in inch per day, in inches per day, that means 1 day. How fast is it filling? That they want unit rate, not a rate. Okay, so we get the rate of change is 1.5 over 2. That means 1.5 inches of water leaking in 2 days. That's what it means. But they don't want it in 2 days, they want it 1 day. So you need to divide these two, 1.5 divided by 2 in your calculator, and you should get that as an answer. So it's 0.75 inch per day for 1 day. And you don't need to put 1 as a denominator. And then they write it in complete sentences, how fast the water is filling the bucket in inches per day. The water is filling the bucket at 0.1 inch per day. Okay, so make sure that you have your answer in a complete sentence. Very important. The pipe continues to leak at the same rate. How much water in the bucket when the pipe arrives in 10 days? Oh, the plumber arrives in 10 days. Okay, so in 10 days, you multiply that times the rate, basically. The number of days times the rate will get you the answer. Distance equals rate times time. Now, how high it is, remember, distance equals to rate times time. So the rate is this, time is 10 days. Distance in this case is not distance, but in this case, height of the water. Okay? Same thing, height, distance of the water from the bottom. But you don't have to use D equals to T times T. That's the rate, though. That's the rate times the time. Unit rate times the time, 10 days. And you get, after 10 days, there will be 7.5 inches of water in the bucket. Okay? And then define the variable. So it depends. You can define it any ways you want. T is for time, H is for height, because it's height. I would put T for time, H for height for myself. Okay, the height is your answer, so H is your answer here, so I would put H equals to height of water I don't write that much. Okay, what D equals to, no, I'm going to use T. T for times time, how much time it is for the bucket to fill the water in days. So height of water in bucket is H. And let H be the equal to the height of water in bucket. T is the time in days. They use D. I don't blame them. So instead of H equals T, you can put D, or whatever variable you choose. You just need to make sure that, that you defined it as such, okay? And then here use the variable to write an equation. So here's the equation. So I use T instead of D, it should be T. If you use whatever other variable you choose, height in water in a bucket, remember this is height of water, and this is time. That's independent, dependent. Same thing it shows. Independent, dependent, right there. Okay. If the plumber calls and reschedule for 2 days after the original appointment. So 2 days after, because first he said it was 10 days, right? If you notice at the beginning, can't fix it for 10 more days. And he says they want an additional 2 days rescheduled after the original appointment. So that's a total of 12 days. So how many inches of water will there be in the bucket? So basically the height is equal to 0.75 times 12, because for T here, because initially he said 10, but they come back and not pay it, not fix it, and you gave 2 more days, so that's now 12. And then when you multiply it equals to 9, the height. 9 what? The height in inches. Okay, that's 9 inches. So answer it. How many inch of water will there be in the bucket? After 12 days, there will be 9 inches of water in the bucket. That's very important. No. The plumber cancel indefinitely. That means never show up. How long until the 11.75 bucket is filled with water? So we know the height, given height. Okay, now I use T, or whatever variable you use. Given the height of the bucket is 11.75, so it has to equal to 11.75. That's the max it can go. We want to find how many days. Days is time. I can see why they use D though. D for days. And then you solve it. Divide by 75. Use your calculator. That's 15.66666666. They change it into a fraction because they expect that you guys know that 0.666666 is 2 over 3. So the bucket will be full in 15 2/3 of the day. That means how many hours is 2/3? Times 2/3 times 12, 24, cross cancel, 8 Oh, that's 16. 15 days and 16 hours. Okay? And then you fill in this table they gave you. 10 we know from up here. 10 days, the answer was 7.5. So you go back to the, like here for 10 it's missing that. For 12 days it's missing that. For this is 15.66666666. Forever repeating. Okay, that's how, but we know how to get all the answers from up here, so and then you use the graph to put those dot in to the dots. 1 and 1.75 right below it, 3 and 2.25, 4, 10. 10 is our next ordered pair, 12, and then 15 and 11.7. So it should look like this. Okay, the next question is, should the line, does it make sense to connect the points? If so, connect the dot points on the graph. Well, they connected the points. Explain your reason. Explain why. Okay, I would say because time can be made lower into days, seconds, minutes, hours, so hours, minutes, seconds, and days. All of them are coming and even lower, so it is continuous. Time is continuous. There's no breakage. So you connect them. And water dripping, there's no real breakage in that either. So that's why we connect the dot. It makes sense to connect the dot because the pipe is leaking at a steady rate, or time is, that you can look at it too. List the independent variable, dependent variable, slope, and y-intercept. Then describe what type of function the equation is. Okay. Dependent, annotate. Y, X, X. Slope is not X, slope is M. And y-intercept is 0, this number we need to find. Then describe the type of function this equation is. It's a linear equation, no problem. Okay, time is the independent variable, and height of the water in the bucket is the dependent variable. The slope we found, remember, slope is rate of change. At the beginning right here, we were calculating slope, rate of change. Okay? And y-intercept. Okay, the equation represents a linear function. Basically, it's a straight line. Slope is this. Y-intercept is this. Okay? And that's your homework. The height, the y-intercept is at 0. 0, because you look at the graph right here. X-intercept's the same. 0, 0.